Hello, math students. How's it going? This is Gary Parker. I am your Quantitative Literacy 2 teacher this quarter. I just want to show you a couple of things about the course and getting started. All right, so hopefully you logged into Canvas and saw that for Math 92, Quantitative Literacy 2, we're going to do all our work in MyOpenMath, and we're not going to do anything in Canvas. To do that, you'll need to log in with the account that you had for Math 62 and then enroll in a new course from your home page. And that course number is 17211. Okay, so right there, course ID. So you'll need to enter that. When you do that, eventually you'll end up at this page here. So you've got the calendar at the top showing due dates. Originally, I had 3/1 due Wednesday because I was hoping we would start school on Monday, but that didn't happen. But we got plenty of time to get stuff done, so we can move dates if we need to. Course information has some just general information about the course. It's got the syllabus. You want to take a look at that. But it's pretty straightforward. A little bit different than last term. You need to have a homework notebook, a 3-ring binder, and in there you're going to collect these lessons. These are worksheets that we'll do in class every day, all quarter. And you'll do them each day, you'll turn them in, I'll grade them, I'll give them back, and you'll need them to study for the exam. Aside from the first section, each section will have a prep, getting ready for it, then the worksheet that we do in class together, maybe some take-home part to that, but usually not, and then some homework you'll do online after class. In class, mainly, it's doing the worksheet and possibly going over questions from either the prep or the homework. But usually the prep and the homework happen after class. So right now, what you should do is take a look at lesson 3.1. If you can print it out, great. Otherwise, scribble your work on a piece of paper and bring that into class with you on Friday. Hopefully we'll have class on Friday. This lesson is all about patterns and being able to continue a pattern and then turn it into an equation. And then the next section will play more with some cool equations. So for example, here we have a pattern that's an x, and the x gets bigger each time. Well, how does it get bigger? Let's play around with that. So I'm going to do a couple of the examples here. I'm not going to do them all because I want you to have some fun with this. I don't want to spoil all your fun. All right, so let's see. Starting off with lesson 3.1, we're looking at patterns and equations. And our first pattern has some x's made of dots. So we have that pattern there. And then building off that pattern, with a slightly different color, we add a little around that x. All right? And so what we want to do is be able to extend the pattern and then describe the pattern algebraically. And then this one gets built up by putting another 4 around the edge of the x. All right, so we can build these suckers all day long. So the next thing I'm going to do underneath here, I'm going to list what I see numerically. So in the first one, I see 5 dots. In the next one, I see those 5 plus 4 more, so I see 9. So just note, to get from here to here, I'm going to add 4. And that pattern is pretty consistent, right? We just keep adding 4. And this kind of pattern is called a linear pattern. Here we do the same addition or subtraction over and over again. What do we have next? 9, 10, 11, 12, 13. All right, so I have to pause to count on my fingers there. So we just keep over and over again. So the next one, I'm not going to draw it, but we just keep adding 4. And so notice how I'm writing all this stuff down. And so bottom line is, to do math, you got to write stuff down. So I expect you're going to have to write a whole bunch of stuff down. I think 17 is the next number. I just want to keep moving this on and on and on, sort of. All right, back to that worksheet. So we have different stages here, and they have an nth stage. So n is going to be our variable ultimately. And I'm not going to worry about what I see. I already talked about that verbally. You can write down, I see an x with 5 dots, number of dots. So putting that over here, let's make a table where we have the stage versus the dots. And so we have the first stage has 5 dots, and the second stage has 9 dots, and the third stage has 13 dots, and the fourth stage has 17 dots. And then a cool thing about this pattern is that as we move through this column here, we just keep adding 4, right? And so we've got a nice consistent pattern. As we move up for each stage, the number of dots jumps up by 4. And so here I'm just going to make a note about some arithmetic we're all familiar with, that when you repeatedly add, that's the same thing as multiplying. So in this case, I have 3 times 4 gets me to 17. So starting with 5, add 3 4s, that's 12, 5 and 12 is 17. So the bottom line, as I move down, if somebody says, well, just later down the line, like I want to find the 10th figure, I had some number of 4s going on. So I'm just going to make a wild guess at this. I'm going to say, well, maybe it was just 4 times 10, 40 dots. Right, question mark. If I go back and test that, for the fourth figure, that means there should be 4 times 4 or 16 dots, but I notice I have 17. That's close. In the third figure, 3 times 4 would be 12. That's close. And in the second figure, I have 3 times 2, which would be, 4 times 2, which would be 8. That's close to 9. So it looks like when I try to multiply 4, right, the amount we're jumping by the stage on that, I almost get the number of dots. So I think if I just tweak this by adding 1, then I'm good. So I can guess at the formula. So if somebody said, hey, what about the nth stage? Well, n is a variable. It could be 4, it could be 10. But I think what I would do is I would take 4 times the stage that I'm at, and then add 1 to that, and that should give me the number of dots. So just double checking that, if n equals 3, this formula says to take 4 times 3 and add 1. 4 times 3 is 12, plus 1 is 13. Is that what we had? Check it out, it works. Okay, so we were able to look at the pattern. Important things about this are that we made some notes about, we wrote down the number of dots we saw, and we wrote down how we jumped from one number to the other. So it's one thing to make those observations and say them out loud. It's another thing to write them on paper. Writing them on paper frees your mind to explore what's going on. Right, so that's why it's super important. Whenever you're doing math, write as much down as possible. Brainstorm. That's what we're doing here. Let's try another one. Let's do one that's a little bit harder. Let's see what the worksheet has for us here. All right, I think you'll have no problem with number 2. Number 3 is interesting. Let's try number 3. So number 3, we start off with 2, oops, you can't see my screen. Here's my screen. There it is. With 2 rectangles. Those are my rectangles. Let's do that again. So here's 1, and here is the other. That's the first figure. The second figure, what does that look like? Okay. Second figure looks like this. And the third figure let's see, That one looks like this. And so sometimes describing what we see can be powerful. So let's see, what do I see? I see 2 squares. And over here I see like 4 squares. And over here I see 6. All right. So my wife, who's a little bit more of an artist than me, she would say, well, it's not just that there's 2 or 4, it's 6. That 2 is really 2 rows and 1 column. And in the next one, we'd have 2 rows and 2 columns. And the next one, we have 2 rows and 3 columns, right? Because there's lots of ways to put 6 together, but these are very specifically organized. So is it true that the next one is 2 rows and 4 columns? And I think that's what I saw in the picture. Yeah, check it out. Better, check this out, this is cool. Yellow highlighter. The number of columns turns out to be the stage that we're at too. We could easily identify if someone said, hey, well, what about stage 10? What's going on there? And we could say, well, in stage 10, there's always going to be 2 rows, but there will be 10 columns. So you just see a total of 20 squares. And then if we generalize that to some n, where n could be 2 or 4 or, the 10th stage, it looks like we would always have 2 rows and n columns. Or we could write that as 2n. You just plug in what stage you're at, double the stage, that gives you the number of squares. Okay? So sometimes we can turn patterns into a formula. Is it always easy? Not really. Sometimes it can be hard. So I'm going to let you play with number 4 and number 5 and number 6 here. You'll find that they're similar but slightly different. I think number 6 is the trickiest one. It does say challenge there. All right, so once we get that tied up on Friday, hopefully we'll get to meet Friday, then we're going to play around with some funner stuff here, taking a look at balancing blood alcohol. And so we're going to analyze an equation that somebody came up with for estimating one's blood alcohol level as a percentage of alcohol per volume blood, given a few things about the person, like are they male or female, how many drinks did they have, how long ago did they have those drinks, and how much do they weigh. And given that information, we can then estimate their blood alcohol level and then be able to make determinations like, are you safe to drive right now? So this is going to be a pretty cool one that we'll explore. Now, to use this formula, we'll have to play around with substituting in equations. And so the prep for 3.2, if you could take a look at that soon. So again, what you should do is try that worksheet, do as much as you can. Make a note of any questions you have. Bring those to class Friday. Give the homework for 3.1 a shot. That just extends what we did in the worksheet. And then take a look at the prep and do as much as you can in the prep. Let's take a look at one of these. So here, a little more, play around with just evaluating formulas. And most of these have videos to go with them. So here someone says, okay, we're going to take 10 times some number raised to the 4th power minus 3 times some number to the 2nd. And they tell us what those numbers are. So let's give that a shot. Let's see. I'm going to shrink my screen. Copy that in here. Shouldn't be too. Didn't go well. Nope. I can shrink that a little bit. All right. Let's get a new page for this. Okay, so we have the formula 10 x to the 4th power minus 3y to the 2nd. And we're given that x is equal to, I think it is 2, when y is equal to 5. Is that true? Yeah. When we're doing substitutions, we always want to be safe and use parentheses. So I would rewrite this as 10 parentheses to the 4th. minus 3 parentheses 5 to the second. And then following the order of operations here, let's see, order of operations says you got to do what's inside parentheses first. Well, there's just a 2 in there. There's nothing to do. And also with order of operations, we usually go left to right. So actually a quick review of the order of operations might be a good idea. Load this up. Let's see how do I do that. Oh yeah, that's not bad. So the order of operations is 1 to do what's inside parentheses. 2, we do any exponents next. 3, we do any addition or subtraction. And we do those from left to right. And then the 4th step is to do any multiplications or divisions. And depends which one we do depending on how they occur left to right. So kind of in general, we have a left to right theme. And the order of operations, although it says 1, 2, 3, 4, isn't always 1, 2, 3, 4, because what we have to do is jump around the problem. So here I just kind of read it left to right, and I see parentheses. So I say, okay, what do I do here? There's really nothing to do inside. So I would jump up and do the power next. So 2 to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So I think I have 10 times 16 minus, and then over here, I have to do 5 squared, which is 25. So I'm going to have a 3 times 25. Okay, and then before I can subtract, I have to do these multiplications here and here. So 10 times 16 is 160. 3 times 25 is what, 75. And so then subtract those suckers. Let's see, I think I'm going to need a calculator or to stack them. 160 minus 75. And so I have to make that a 10 and borrow from the 6. So that's going to be what, 5. I can't do 5 minus 7, so I have to borrow. And so 15 to 7 is what, 8. So I get 85. Double check. 5 and 5 is 10. 8 and 7 is 150. Plus 10 is 160. Yeah, that works. All right, so it looks like we get an answer of 85. And we could always plug into a calculator. I don't know if you ever noticed that Google is a calculator. So for example, if you open up a web browser like Chrome, and in the search bar, either down here or up top, you type something like 2 plus 3, it whips up a calculator. So then I could do something like clear that and then type my expression 10 times parentheses 2 squared, there's the square button right there, minus, what was next? It was 3 times parentheses 5, close parentheses, square it, enter, and it says, hey, the answer is negative 35. Uh-oh, what did I do wrong? Oh, it's supposed to be 2 to the 4th power, wasn't it? So the calculator only does what we tell it. I told it to do the wrong problem. Try it again. 10 times 2 raised to the 4th minus 3 times 5 raised to the 2nd. There we go, 85. Got the answer I want. So you get to play around with this particular exercise and try them out. Let's see if I got it right. 5, submit. Excellent, I got it right. All right. If anything seems hard, you don't get it right the first couple tries, it's always a good idea to try a similar one. Okay, have fun, do good math. Hopefully I'll see you all on Friday. Take care.